Let's do some series circuits here. So examples. And this is where we left off with the last video. We said that the voltage drop of the battery is equal to each individual voltage drops across each resistor. So we could write this in equation form. The voltage of the battery is equal to voltage of resistor 1 plus voltage drop across resistor 2 plus 3 if there is a 1, and so on and on and on and on. And we actually mentioned on Monday this rule and why this has to be the case. This is known as Kirchhoff's loop rule, and it's the circuit version of conservation of energy. So if you come down a water slide, whatever potential energy you dropped going down the water slide, that has to be equal to the potential energy you gained by going up the water slide. That's conservation of energy. Now remember, voltage is an energy, it's the energy per charge. So you could think of voltage as like the energy per person if we were all identical at the top of the water slide there. So let's do a couple quick examples of these and then a few more fuller examples using all the stuff that we've learned. If we have a 120 volt battery and we know that this light bulb has an 80 volt drop, then what must be the voltage drop across this one? 40 volts. We have to use up all the voltage of the battery no matter what. So over here we have a 12 volt battery, a 3 volt drop, and a 4 volt drop, which makes this third drop over here have to be equal to 5 volts to get up to a total of 12. All right, now this one uses everything we've learned so far. Let's say we have this circuit over here, a 60 volt battery with a 17 ohm, a 12 ohm, and 11 ohm resistor. First job, let's find this, the equivalent resistance. Simply add them up. 17 plus 12 plus 11 gives you 40. So 40 ohms is our total resistance. Now, to find the total current, that means how much current flows out of the battery. We're going to use Ohm's law in this form right here. Voltage divided by resistance is the current. Remember, we got to use the total resistance. So 60 volts divided by 40 ohms gives us 1.5, and I just wrote it as 3/2 here. So 3/2 amps come out of the battery. But this is a series circuit, so that means 3/2 amps or 1.5 flow through all three of these resistors because the current is the same everywhere. Now we can go and find the voltage drop across each device. How do we get the voltage drop across resistor 1? We use Ohm's law again, just in this form. Voltage is current times resistance. So we know 1.5 amps flows through this 17 ohm resistor, so 1.5 times 17 is 25.5. We repeat that for resistor 2 to get the second voltage drop. 12 ohms times 1.5 amps gives you a total of 18 volts drop, or are used up in a sense in that resistor. And then we repeat it again for this one. 11 ohms times 1.5 amps for resistor 3 gives us 16.5 volts. So what, by the way, is 25.5 volts plus 18 volts plus 16.5 volts? So what's the voltage drop across all three resistors? 60 if you add those up, which we actually already knew that answer because the voltage drop across all three of these has to be equal to the total voltage of the battery due to Kirchhoff's loop rule again. So let's do another example here. Let's say we have a 12 volt battery and an 11 ohm, a 7 ohm, and a 20 ohm resistor. First thing, let's find the equivalent resistance by adding them up. So 11 plus 7 plus 20 is 38. Now let's find the current coming out of the battery. We do voltage divided by resistance. So 12 volts divided by 38 ohms gives you 0.316 rounded off amps. And remember, that is the same that goes through all three of those resistors because it's a series circuit. So now let's find the individual voltage drops. To do that, we're going to use this form, the current times the resistance. So 0.36 amps times 11 will give you 3.48. 0.316 amps times 7 will give you 2.21. And 0.316 amps times 20 will give you 6.32. So this is how much voltage each of those resistors are using up out of the 12 volts of the battery. What happens if we add up all three of these voltages? We should get 12, which actually, if you do that, you will get 12.01 due to rounding differences there. I'll have one more video that's sort of optional if you feel you need some more examples, but this should be really enough to get you through the puzzle problems, which are the last thing to do for today.